Hi guys, let's see what do you mean by choke coil. Choke coil is a coil with high inductance but very low resistance. It is used to limit the current, obviously in AC, but with very small power losses as heat. That's why we keep the inductance high. So to increase Z, but we keep resistance low so that power losses are less. So it is basically a coil. When connected across an AC, the Z, which is XL square plus R square whole root, is omega square L square plus R square root of that, is very high, or we can say is tending towards omega L, as R is very small as compared to omega L. For a good choke coil, we can say that as XL is very large as compared to this 10 phi, which is XL by R, will tends to infinity, or phi will tends to pi by 2. Okay, current will lag by pi by 2, almost by pi by 2. Okay, but it is almost impossible to make a coil with inductance only with no resistance, because the coil is made up of some resistance. Okay, so we will also say that choke coil acts as a resistance of very low value if a DC source is applied. Okay, for a DC, we can say the resistance offered is R. So we can say I is nothing but VDC by R. But for NAC, I is equal to VAC by Z, which is very high. Okay, so this is how a choke coil works. Let's take an example of a choke coil and we find it in day-to-day life. So let's say a voltage source is V equal to 100 sine 100 pi t. Resistance is 1 ohm and this is 1 by pi Henry. Okay, so what is XL? In this case, XL is omega L, which is 1 by pi into 100 pi, means 100 ohm, and resistance is 1 ohm. So what is Z? Z is 100 square plus 1 square root of that, is very similar to 100. And what is phi? Phi is 10 inverse 100 by 1. So it is very close to 90 degree. Phi is very close to 90 degree. What about the equation of current? Current will be V naught by Z sine 100 pi t minus phi. As it is an inductive circuit, so current will lag by this much phi. V naught by Z is I sine 100 pi t minus pi by 2. Again, the current has reduced to a very small value, which is 1. But still the power losses are very low. Okay, the current can be reduced to a very low value by increasing the resistance, but again, by increasing the resistance, power losses will also increase, which we don't want. So we increase XL, but it don't cause any power losses. Okay, enjoy.